Hello everybody, and welcome back to part 3 of my new lab bench power supply. If you've seen part 1 and part 2, this part 3 will describe a couple of improvements I've made to this power supply. Number one, I had this 80-year-old switch that was right here, and it was a little bit flaky, so it's past its time, so we replaced that with another double pole double throw switch. The most important change I made was the meter that I added here is monitoring the voltage output of these banana jacks here, the 7, 14, 21, 28 volts. So let's turn it on. I'll let it boot up a little bit here, pretty quick. And you can see that in this position right here, we have, it's really 6.3 volt windings. And again, we're just going to meter it, 7. Right out, coming out of here now is 12. Coming out of here should be another 6 volts, 6.3. So we have 20. And then the last position coming out of here should be about 27, which it is. Okay, so that's all we did. Just added a little more convenience. Wish we could have made this volt and amp meter like these two. I just couldn't find one that would power itself off of 30 volts or this 27 volts coming out of here. The meter's actually minimum requirement was 30, but it's working pretty good at 27. But I looked around, just could not find one that would also meter the amperage or the current going through here. So let's have you take a look at the power supply's schematic diagrams, which I have over here. Okay, here we're looking at the schematic diagram of the power supply, and let's go over it real quick here. Here's our isolation transformer, and here's our 120 volt AC mains, and then on the other side this transformer puts out about 130 volts. It's going through this toroidal transformer that gives the current indication for this volt amp meter that you saw. Now, this volt amp meter is powered by AC, and you can see these two leads here go to here and here, which puts it 130 volts across this meter, how it gets its power. At the same time, these two leads are also on pole double throw switch, pole 1 and pole 2. So you can see in this position, both outputs or leads on the output transformer are going to the bridge rectifier. The output of the bridge rectifier goes to this filter network, and then on into the meter that is giving us our DC current and voltage. And we get about 177 volts out with a no load condition. With the switch in the other position, when it's down here and down here, you can see that the output of the secondaries goes right into the outlet on the front of the box. It's just an AC receptacle. So that's it for that. Okay, now we're looking at the diagram for the filament supply for vacuum tubes. Again, here we have our 120 volt AC on the primary. Each tap has 7 volts. They're actually 6.3 volts. According to the specifications, but with my little bit higher voltage here, I'm getting about 7 volts across each of these windings. So this one is the common winding, and the last winding, you can see they're all in series. I series these so that we get a total from common to this last winding 28 volts of AC. So so we do have our 7, 14, 21, 28 depending on which tap we're looking at. Here's the meter. It's monitoring the voltage only, AC voltmeter, and here's the meter switch. And as you can see, the meter switch just simply has a connection across each one of the outputs here. So very simple, that's all there is to that. And with that, I think we're done with the project. Thank you for watching. I appreciate you comments and suggestions. And we'll be back with another video. This one's pretty much over with. So thanks again for watching. Thumbs up was always appreciated, and we'll see you next time around. Bye now.